Welcome to Lab 3, where we'll discuss data acquisition using the Arduino board hooked up to an accelerometer. In this lab, we'll also discuss the relationship between sampling rate, Nyquist frequency, and aliasing. In this lab, the only new device that you'll see is an accelerometer mounted on a breakout board. You'll also use an Arduino as well as jumper cables to connect the two devices. The metal arm that you see will be used for securing the accelerometer and providing motion during data acquisition. The new device that you'll be using, an accelerometer, is a sensor that measures acceleration via changes in voltage output. This particular accelerometer is a single-axis accelerometer, which means it must be mounted in the direction of acceleration. You can also find triple-axis accelerometers, which measure acceleration in all three directions. The wires that you see must be soldered to the accelerometer and connected to the Arduino board. Information on how to properly make these connections can be found in your assignment and in the accelerometer datasheet. You can also find a brief tutorial video on proper soldering technique in the resources section of your assignment. The breakout board on which the accelerometer is mounted essentially replaces the breadboard circuit that you see in your assignment. This allows for direct connection between the accelerometer and the Arduino. Two important concepts in data acquisition are Nyquist frequency and aliasing. The Nyquist frequency is half of the sample rate and must be greater than or equal to the frequency of the highest frequency component of the system in order to ensure accurate data acquisition. As a result, the sampling rate must be at least twice the frequency of that component. Any information occurring above the Nyquist frequency might be confounded during data acquisition, and that is known as aliasing. In aliasing, signals become indistinguishable from each other and can seriously distort results. You can find more information on this in the resources section of your assignments document. To run the experiment, once the accelerometer is attached to the metal arm and the code has been uploaded to the Arduino, simply depress the metal arm and release. Once the metal arm stops oscillating, you can disconnect the Arduino to stop data recording. The breakout board of the accelerometer should be mounted perpendicular to the metal arm. This may require using a separate piece to mount it vertically. You can use clamps or a heavy object to secure the metal arm to a table. The Arduino code declares one integer sensor pin, which denotes the pin that connects the Arduino to the accelerometer. In the setup, serial begin sets the data acquisition sample rate, and pin mode sets the sensor pin as the input. In the loop, analog read reads the value from the sensor pin, and serial print prints that value to the serial monitor. Delay determines the rate at which this data is printed to the monitor, and you can increase resolution by decreasing the delay value. Once you've gathered your data and are ready to put it into MATLAB, you should familiarize yourself with functions and scripts, which you can do via the MATLAB link in the resources section of your assignment page. Although the assignment includes all of the functions that you'll need to do the MATLAB analysis, familiarizing yourself with these concepts will be an excellent tool for further use of the program. If you are running into difficulty with data acquisition initially, your problem is likely with the hardware. You should first verify that all wires connecting the accelerometer to the Arduino are going in the proper Arduino ports. If they are, you should also verify that the wires are properly soldered to the accelerometer and that all connections are good. When running MATLAB analyses and Arduino supplementary exercises, you may run into a number of software issues. The first thing to check is to verify that parentheses and brackets are properly closed. You may also want to check that proper ports are declared in the Arduino code and that there are no misspellings in your MATLAB functions. If the accelerometer is recording but isn't registering any variation, You should check to make sure that the arrow on the breakout board is pointing in the direction of accelerometer motion. Since the accelerometer is a single axis, it will only measure acceleration in that direction.